Hi, grade nines. I'm going to go back to yesterday's question and I'm going to look at the scatter plot again. That was about the temperature and the number of customers. And today we're going to look at that problem and we're going to use algebra to solve those questions that we looked at yesterday rather than just looking at the graph. Okay, so let's look at the graph again that we made yesterday. We made a scatter plot and then we made a line of best fit. So let's remind ourselves of what that looked like. We'll also look at the equation that Desmos gave us for the line of best fit. We entered the equation y1 squiggly mx1 plus b, and then Desmos came up with a number for m and a number for b, a number for the rate of change, and a number for the initial value. Okay, so this is what Desmos gave us. It gave us y is equal to 11.6336x minus 420.55. Remember that the y is the number of customers and the x is the temperature. Just so that our equation makes a bit more sense to us, we'll change the x and y to t and c. So our customers are going up 11.6336 every time the temperature goes up, and the customer started at minus 420.55. Okay, so that's great. Yesterday we saw that equation, and yesterday we also answered some questions. So let's remind ourselves of the questions from yesterday. The first question was, how many customers would we have if the temperature was 90 degrees? So let's remember that temperature, that's the letter T. We want the T to be equal to 90. So that means if I had a table of values, here would be my T, here would be my C. When temperature is 0, it starts at minus 420. 1, 2, 3, and it keeps jumping up the customers by 11.6336. For us to go and make our table of values go all the way to 90, that would take a really long time. So what we want to do instead is we want to use the equation. We want to use the fact that it starts at minus 420 and it's going up 11.6336 90 times. So what we want to do is we want to say that my customers would be equal to 11.6336 times 90. And at the beginning it was minus 420.55. I'm hoping that that's going to give me the same answer as the graph did yesterday when I did it. So I'm going to get my calculator and I'm going to check. On the graph, we saw that when there was a temperature of 90 degrees, there should be a little bit more than 600 customers. So hopefully my equation was going to give me the same thing, and it did. When I did 11.6336 times 90, subtract 420.55, I got 626.474. That means when the temperature is 90 degrees, remember it was Fahrenheit, there should be about 626 customers. If my algebra or my equation would have given me something different than the graph, then I would have realized I made a mistake somewhere, because the equation and the graph both should relate to each other and they should give you the same answer. Okay, so let's look at our second question from yesterday. Okay, So this time in the question, it tells us not the temperature, it tells us the number of customers. It tells us that the customers are 700. So we're not going to put the 700 where the T is. We're going to put the 700 where the C is. My son is sitting down and ruining my video. Okay, there's his arm. Okay, so let's look at a table of values. That means that 0, 1, 2. We don't want to get 700 in the temperature. We want to get 700 in the customers. So we know, for example, we just did in the question that when there's 90 customers, no, when the temperature is 90, there are 626 customers. We know that at the beginning, there should be negative 420.55 customers. We know that my table is jumping by 11.6336. I want to know how many times do I need to jump up 11.6336 to finally get to 700 customers. So I could use trial and error. I could just try 11.6336 times 95 minus 420.55. I could try different things until I got an answer close to 700. What I'm going to do instead is I'm going to use algebra. A lot of you call it balancing the equation because I think that's what Ms. Fazakosh called it last semester. So let's write down our equation. My customers equal to 11.6336 T minus 420.55. We know the customers are 700. So instead of putting a C there, I'm actually going to change my C into the number 700. Can I do this? Okay. And what I want to do is I want to leave the T part by itself right now. And I want to move the part that doesn't have a T to the other side with the 700 because the 700 does not have a T either. You can think of it as this is a number that has to do with rate of change. This one isn't, and this one isn't because they don't have T's. So those two numbers want to go together. So to balance or to get rid of this minus 420, the opposite of minus 420 is we're adding 420.55. It's an equation. We're going to do the same thing to this side to keep it balanced. These two, the word in English is cancel. They cancel each other out. They give you 0. So all I have now is 11.6336 T. And on this side, I have 700 plus 420. I think my math is going to tell me that's going to be 1120.55. And then right now, these two are multiplying, the 11 and the T. The opposite of multiplying is dividing. And these two are going to cancel then, so all I have is T. But if I divide this side by 11.6336, I also need to divide the left-hand side. Okay, so I'm going to get my calculator here. My pen is rolling. And I have 1120.55 divided by 11.6336 equals 96 degrees. So that means that when the temperature is about 97 degrees Fahrenheit, you should have 700 customers at your ice cream store. I hope that helped you today. If you have any questions, send them my way and I'd be happy to help you. Don't forget your assignment is due this weekend.